Hello, everybody. Hopefully, everybody is safe and well. This week, week number 11, we're going to look at 10.1 and 10.2 in conducting hypothesis testing involving a population proportion. Last week, it was hypothesis testing involving one population mean. Okay, so in order to conduct hypothesis testing involving an unknown population proportion, our test statistic value is going to be distributed according to the standard normal probability distribution, so it's a z-variate, and the formula to compute the test statistic is going to be the sample proportion, p hat, subtract the purported population proportion under the null statement, divided by the square root of p naught, again, the purported proportion under the null statement, times 1 minus p naught, divided by the sample size n. So this is the test statistic that we're always going to be using when conducting a one sample hypothesis test involving a population proportion. All right, the first problem we want to look at is a two-tailed test. It reads this way. In a study of 420,095 Danish cell phone users, 135 subjects developed cancer of the brain or nervous system based on data from the Journal of the National Cancer Institute as reported in USA Today. Test the claim of a once popular belief that such cancers are affected by cell phone use. That is, test the claim that the cell phone users develop cancer of the brain or nervous system at a rate that is different from the rate of 0.0340% for people who do not use cell phones. Because this issue has great importance, we will use the 5% significant level to test the hypotheses. Should cell phone users be concerned about cancer of the brain or nervous system caused by cell phones? We're going to show all 5 steps and conduct the test on the calculator. First of all, we'll show you the critical value method in showing all 5 steps. The first step, like we showed last week, was to clearly identify the hypotheses that are being tested. Remember, for the alternative hypothesis statement, your mathematical symbol always has to be one of these 3 possible symbols: not equal to, less than, or greater than. Since we're testing the claim that the rate of cancer development is different from 0.0340%, different suggests not equal to. So that will be our alternative hypothesis statement. So the alternative hypothesis H1 is going to be that the unknown population proportion is not equal. Now we have to turn this percent into a decimal because a proportion is cited as a decimal when doing hypothesis testing for a population proportion. So we move the decimal point 2 places to the left, so this is going to be, and drop the percent symbol. So it's going to be 0.00034 and an optional 0. The null hypothesis, on the other hand, is going to be that the unknown population proportion is equal to 0.000340. All right, step number 2 of this procedure will now have us computing the test statistic value, which is based always on sample evidence. And our test statistic formula is distributed according to the standard normal probability distribution. So it's Z is equal to the sample proportion minus P naught divided by the square root of P naught times 1 minus P naught divided by the sample size. Now our sample proportion P hat is going to be equal to 135 divided by our sample size, which is 420,095. And I already did this division, and that we should get 0.000321, somewhere in there. Now to compute our test statistic using p hat, we replace p hat with the 0.000321, and we subtract off p naught, which is the purported population proportion under the null statement, which is to say we subtract off 0.000340. Make sure you put this inside parentheses. All divided by the square root of P naught, which is 0.00034. I'm going to leave the 0 at the end off, times 1 minus 0.00034. And that's divided by the sample size, which is 420,095. When you crank this calculation out, you should come up with a test statistic which is about negative 0.668. Now, how do you type this calculation in on your calculator? You got to be very careful, otherwise you're going to get what is called a logical error. So to type this calculation in on your calculator, you would start by hitting an open parenthesis. Then you would type in 0.000321 minus 0.00034 closed parenthesis divided by, then you got to go get your square root. So you hit your second key followed by your square key to bring up the square root function. And I believe when you bring the square root function up, it presents you with an uncontrollable open parenthesis, in which case the next thing you need to then hit, I would suggest, is another open parenthesis. Type in 0.00034, another open parenthesis, 1 minus 0.00034, closed parenthesis. Okay, so let's see here. Close parenthesis, and then you're going to need another closed parenthesis, and then you will say divided by 420,095, and you need one more closed parenthesis. Then you should hit enter, and it should come out to give you what you need. Okay. So let's see, 2, 3. All right, step number, actually, you know what? Step number 2 is establishing the level of significance, which means we're supposed to test at 5%. So step 2, this should be step 3. Step 3 is the test statistic. I do apologize for that. Step number 2 is setting alpha at 5%. That is the probability of committing a typo and error. Now step number 4 is clearly illustrating with a picture the rejection and acceptance region. And since our test statistic is distributed according to the standard normal probability distribution, we draw a picture of that distribution. This is a two-tailed test, and so therefore we're going to take alpha, which is 0.05, we're going to have it, which is to say that 2.5% of the area of our curve lies in both the lower and the upper tail rejection regions. And we're going to have to find these critical z-values here. Okay, so again, in the upper tail we have 0.05 divided by 2, which is to say 2.5% of our area. And also in the lower tail we have 0.025 of the area, or the proportion of the area of the entire curve. To find your critical z-value here, you're going to use your inverse norm function, which hangs out in your distribution mode. You're going to type in the area to the left of your critical z-value, which is 0.025, comma, and then you're going to type in 0 and 1 for the mean and standard deviation of the standard normal distribution. When you do this, you should get, for a critical z-value, you should get about negative 1.96. So we have two critical z-values, negative 1.96 and positive 1.96. These are the values that separate the rejection from the acceptance region, or the do not reject region. Step number 5 is drawing a conclusion now that as to what we're going to do with our hypotheses. And that is determined by comparing our test statistic, which is negative 0.668, and where it lies in relation to these critical z-values. Well, we can clearly see that negative 0.668 lies in between our two critical z-values, so it falls very safely in the do not reject region. And therefore, sample evidence is not strong enough to support the claim. And the claim was that the proportion of people that suffer from cancer due to cell phones is different than 0.0340%. Since we cannot reject the null hypothesis, the claim is not being supported by sample evidence. So in conclusion, we can say that sample evidence is not supporting the claim that the percent of cancers of the brain caused by cell phone use differs from 0.0340%. So that concludes this two-tailed test of testing for an unknown population proportion.